Hi, my name is Sandeep Sharma, and I'd like to welcome you all to a video presentation on a simple traffic engineering using SDN.
Now, before I move forward, I quickly like to talk about SDN. So, SDN is nothing but a separation between the control plane and the data plane between the network devices. We do this so that we try to minimize the complexity of the current legacy network. Now, as we know, the modern computer network in general is very complex, and there is a huge challenge to manage this network. With SDN, we try to touch this complexity part and make the network management very easy. And SDN also tries to bring innovation in the field of networking. To give a simple example of how the current network is complex and it's very difficult to manage them. Let's say there is a network where we have four routers and we like to configure these devices. Now, in order to configure the devices, we have to individually log into each of these devices through a command line and start configuring them. Now let's say instead of four devices, our network is very large and we have like thousands of devices. So we can just imagine the amount of time and resources it will take to configure each of these devices individually. Now let's try to talk about the complexity. Let's say I've configured the OSPF route protocol on all these devices individually. Now after I finish configuring this OSPF, now since each of in a legacy network, each of these devices will have their own local control plane, which is actually the brain of these devices. So each of these devices will now try to find out what is the network around them, and they exchange the network information among themselves so that they can find out what the network actually looks like. But this is actually a very inefficient way of finding the network topology, and it's a very complex. And even after all this effort that we put into, none of the devices is able to have the complete picture of how the network look like. How SDN brings innovation in networking. I like to explain this with a simple example. As we know, a network will be a collection of many devices, and usually a large network will consist of like thousands of devices. Now, each of these devices can be from different vendors like HP, Cisco, Huawei, Juniper, and etc. And each of these devices from different vendor will run their own proprietary OS. Now, because of this, it will be a very difficult to introduce any new protocol and run them on these devices, which belongs to different vendors, which have their own proprietary OS running on them. Uh, just imagine that you have invented a new protocol which is very fast and efficient to find the route. Now, even though this protocol is very fast, but it will be extremely difficult to make each of this vendor to run this protocol on their OS. So, because of this, you cannot develop a new protocol and just install them in the devices because the OS of these devices are proprietary, and you cannot simply access them unless the vendors uh, uh, whom these devices belongs to agree to include that protocol in their devices. So in this way, because of this proprietary OS operating system running on each of these devices, uh, innovation is hindered. With this simple example that how when different devices have their own control plane running their own proprietary software, uh, we are not doing much uh, good for the innovation that we can bring to our network. Okay, let's try to look at the architect of an SDN network. So as we talked before, in SDN we separate the control plane and the data plane between the devices. So we will have a devices, but these devices will just be having the data plane, which is just a simple hardware which will be responsible for forwarding the packets from one port to another. And we have the control plane is moved to a centralized system which is called the controller, and each devices will have a single controller with which they will be communicating over the southbound interfaces. This interface between the controller and the SDN devices is called the southbound interfaces, and they use open flow protocols to communicate with each others. Now, also we have the app, as we said, innovation. So this is where the innovation comes from. We have an app through which this app can direct the controller as what it wants to do with the networking devices, and the apps communicate with the controller using the north bound. Okay, that. So the part where our networking SDN networking devices resides, uh, they are called the infrastructure layer, and the part where our controller is, it's called the control layer, and the part which we have our apps which communicate to our controller is called application. So the architecture of SDN network will consist of the infrastructure layer, the control layer, and the application layer. So we just talk about the SDN architect, and I also need to implement the same architect when I'm designing my project. So for the infrastructure, I use the Mininet software uh, to simulate my SDN devices, and for the control layer, I use the HP SDN controller. There are many other controllers available too, but I was able to find documents and support for SDN controller, so I'm using this controller. But of course, there are other controllers that could be used. And for the app part, I didn't design a full-fledged app, but what I'm doing is I'm writing a bash script, and I push this script to my controller using Perl, so, to a controller, and then I control the flow in my devices. This is how I'm using Mininet as the end controller and a simple script to in my project, and I'll show you more as I give you the demo of what my project does. So I like now to talk about how do I set up my network for my project. So I have my PC and that connects to a networking device or an adapter, and then I have two I need two servers, one that is running mininet and another one which will run my HP Sdn controller. So uh, this computer will have the IP 192.168.56.1. So this is the IP address of my controller, and for the mininet the computer will have an IP of 192.168.56.50, and I also like to I need my PC to be on the same network, so I put my IP 192.168.56.1, and this adapter can have on same network 192.168.56.2. So I have my network built like this. So this is the setup of what my network look like, and I'll show you, like for this mininet and HP controller I'm using not a physical device but virtual machines that I'm using, and I'll show you how I set up my net. In order to set up this network, I have downloaded the virtual machine of HP SDN controller and mininet. I'm going to start it now. And as we can see here, I've made my PC dot two, and this connects to my this PC connect is connecting to the using this virtual box adapter to this, and I have set this port dot one, and we have our two virtual machines. So this one is a mininet. I log in with the username password. I have config here. Here, this is my PN controller. Here we can see us the IP address is 192.168.11. So from here, I like keeping my mininet VM, which is 192.168.56. 50, I can ping it, so my network is set up. Let's start building the infrastructure. Uh, we have both our virtual machine running. I can access the GUI of my Sdn controller. Topology here right now, I haven't built any topology. Now using the mininet, I can design a topology. Okay. So here is one simple example uh, where uh, I'm designing a linear topology, uh, and I'm pointed that my SDN server, SDN controller IP. So when I hit enter, so it's created the four switches here in our HP WAN controller. We can see our linear SDN switch has been created. But I don't want uh, this linear type of topology. I want to create my own custom topology, which I can do. I want to build a custom topology. So my custom topology will look something like this. I'll basically create a star topology. So I have like this. Maybe this connects to here. This connects to here. And each has like couple of hosts. This H1, H2, H3, H4, H5, H6, and this is one G G1 server. So I would like to create a custom topology like this, so that my traffic from this host to the follow somewhere like this, and then I can manipulate the traffic between the network. Let's see how we can build the topology like this. In order to create a custom topology in Mininet, I need to use Python programming or a Python script in order to create it. And now in Mininet, if I go to cd slash net, there is one example that is given in the Mininet. So if I see that example, so here the example is given like how I can create any type of topology. Let's say how to add host. So I can use like host. Here they are using two hosts, two switches. So I can add as many hosts and switches I want, and how to create a link between, like here they are creating a link between H1, H2, and like this. So if I have like H1, H2, H3, H4, so I can like create link almost like this. So using upon the same example, I have created a star topology. So here I have created using the same example. Here I have created like all my hosts here, H1, H2, H4, as I said, G1, and then these are the six switches that I created. And this is how you create your custom uh, switches. So let me go to my SDN controller. So right now this is my controller, but I have not built my infrastructure, so it's empty. So let me simulate my infrastructure on Mininet. So I open my Mininet. Let's go out. So from here, if I want to generate my topology, so all I need to do is sudo and then Mininet minus minus building a custom topology, and I have save the topology as I shown you above as a Python file like this, and the topo, and I have a function. This is just a general syntax that you need to follow, and I want this to run on my controller. So my controller is remote, because Mininet has an inbuilt controller, but it's not so powerful. You cannot do much with it. So I'm using HP controller. So I'm confirming that I'm not using the inbuilt controller of the Mininet, but a remote controller. And for this, the IP of which, as we discussed before, is 192.168.56.1, 56.11. I create it, and my topology is created. Here I view codes, and here I cannot see the host right now. Uh, for which, if I do like ping all, so I'll see my host too, and click, and so here I build on my topology. So this is how my topology look like. So let's say I want to evaluate the traffic that's going from my host 1 to G1. So let's select host, this one. So not sort of flow. Let's see what kind of flow is that. So right now, uh, there's nothing because it's refreshed. So let me ping from mininet, ping h1, ping g1. We are pinging, so we can see what uh, path it's following. So from switch 3, it going from output port 1 and switch 1, and then it goes to my destination. Default, this is how my traffic is going from my host H1 to my another host G1. Let's say I don't want my traffic to follow this path. I don't want traffic to go to my switch 1. I need to change this path. So how can I do this? Let's check it out. The traffic route, I need to log into each devices and make the change in the configuration. Uh, but using Sdn approach, I don't need to log into each of the devices. What I can do is simply run a program on controller, which instruct the controller to change the flow in this network. So let's see how we can make the changes in the controller. So I see my controller here. So what I have done here is that I have created a bash script, and using a curl I am pushing that script to my controller. So here if I do this, so here I have created a traffic engineering script like te.sh, and if I check it, so what uh, does is, as we can see here, first I have created an authenticity with username and password so that this can access the controller, and then here we see first we are changing the flow at switch S3. uh, this is our switch S3. So what we are doing here is that we are telling it that all IP from 10.2.1, which is going to 10.2.50, we are asking it to perform. Now the output should go to uh, 2. So instead of 1, I want output to go to 2. So this is my switch 3. So from here, then I make another changes. For example, S2, I make same configuration on S2 where I say like IP sources from this to this, output goes to 1. And I similarly, I just make change in the path using my controller. So I have made a change in the path from controller. Let's see if I can just make some change, run this command on my controller, and let's see my SDN switches obey it or not. So let's say dot run the command, and you can see here instantly the path is changed. Now no longer it is going, so I made it a little longer, so it's going from here, switch to, and we are reaching the path. So I'm no longer using this link. I can make my changes. So I no need to log into each device separately to make the change. I can just run. I can make a script or app, and I can run it, and I can push the command to controller, and controller again will change.